Good afternoon. My name is Caroline Delaire and I represent the Aquaya Institute. Aquaya is a nonprofit research and consulting organization dedicated to water and sanitation. Our longest lasting research project is about water quality monitoring, and we are very grateful for this opportunity to share our work with practitioners today. My presentation is about routine water quality testing in Africa, which is where Aquaya's research has focused so far. And in this presentation, I will give you a quick description of the status of water quality monitoring. And then I will pull from Aquaya's research to outline some of the important requirements for establishing robust systems of water quality monitoring, both in terms of cost and institutional capacity. So in most countries, two types of institutions are mandated to collect drinking water quality data. First, water suppliers who conduct operational monitoring to ensure the safety of their treatment and distribution processes. And second, independent surveillance agencies that are supposed to check that all drinking water supplies comply with national standards. In 2012-2013, Aquaya examined the amount of microbial water quality testing taking place in 72 monitoring institutions across 10 countries shown on the map. Institutions were equally split between suppliers and surveillance agencies. The primary finding of this work is shown in the bar chart on the left. The majority of mandated institutions were conducted some level of microbial water quality testing, and this is encouraging. But a much smaller fraction, 54% for suppliers and 18% for surveillance agencies, were meeting the testing frequency recommended by WHO or national standards. So microbial water quality testing is taking place, but it is insufficient. Looking more in depth, the study found that most of current testing activities occur in large pipe systems in urban areas, while small pipe systems and point sources, in other words, the sources used in rural areas, are rarely tested. There is therefore a gap between rural and urban areas in terms of testing. So the typical reaction to this problem is to say, let's build more laboratories, let's give them field testing kits with cell phones to store the data, let's train staff on water quality testing and things will improve. But in reality, there are many examples where this supply-side approach has failed. For example, I will read you a quote from Sierra Leone, which is illustrative of what we see in many other contexts in Africa. So here's the quote. The Ministry of Water Resources, with support from UNICEF, established laboratories in 14 districts across Sierra Leone. In addition, the laboratories were stocked with reagents and instruments with laboratory technicians trained to manage the laboratories. However, due to a lack of institutional capacity and budget, reagents and instruments could not be replenished when they ran out of stock. Most of the laboratory technicians were also retired. Furthermore, due to limited coordination, the Ministry of Water is finding it difficult to have all partners adhere to water quality testing of new and rehabilitated sources. So the quote identifies several institutional challenges beyond mere resources, right? These challenges are capacity, budgeting, staff turnover, poor coordination. And this is only an example from Sierra Leone. We see this situation all the time in different countries. When donor support ends, there are typically no reagents for testing, no money to repair vehicles, etc. So my point here is that the requirements for building robust water quality monitoring systems are a bit more nuanced than just building laboratories or providing test kits. What I'm going to do now is pull from the research done by Aquaya to give you a more in-depth understanding of these requirements. So after the initial assessment in 2012-2013, Aquaya partnered with a subset of the institutions for a longer research project aiming to understand the drivers and barriers to routine water quality monitoring. 26 institutions were involved in this research, and it was a mix of water suppliers and surveillance agencies and a mix of urban and rural. For this research, Aquaya developed two types of tools. First, a capacity diagnostic tool called WaterCARD, which reviews 27 capacity factors such as motivation, accountability, staff turnover, technical capacity, infrastructure, procurement processes, and so on. The second tool was an approach to rigorously quantify the cost of water quality testing, including 4 components: equipment, consumables, labor, and transport, as well as communication. So analyzing the WaterCARD results allowed us to identify a subset of factors that could explain why some institutions achieved their testing targets and why some didn't. So the graphic here shows you the results in terms of 3 success pathways or successful recipes for achieving testing targets. As you can see, the first pathway involves 4 ingredients: motivation and leadership, knowledge, procurement, and transport. So motivation and leadership and knowledge are attributes of the institution's staff. Procurement is about having efficient processes for ordering supplies and equipment. And transport is about the availability of vehicles or transportation money for staff to reach sampling locations. And you can see the other 2 successful pathways also displayed on this graph. So you will notice that motivation and leadership and knowledge are in all 3 pathways. So this means that they are required or necessary. In other words, without a motivated water quality leader and without knowledgeable staff, a successful monitoring program cannot happen. The other factors listed here that are contributing to successful monitoring programs were either institutional, such as efficient procurement processes, good staff retention, or resource-related factors, such as transport, equipment, and infrastructure. Now I'd like to share the cost information that we collected from 18 partner institutions. The graph here represents the cost of 1 microbial water quality test for each institution. On average, we found that 1 microbial test cost African institutions $21. So this number is probably higher than what you might expect, but this is because it includes cost of procuring and importing supplies in country, as well as labor and logistic costs, which are usually underestimated. An important finding here is that recurring costs, especially labor and transport, represent a large portion of total costs. This explains why one-off donations often fail. Building laboratories is not sufficient. Institutions need to budget for and fund staff time, vehicles, and consumables. Now I would like to make a point about different models of water quality monitoring. And for this, I'll use recent results from Aquaya's ongoing research in Uganda. This is, on the left, a map of Kabarole district, which has approximately 300 boreholes and springs, with some of them located in a mountainous region to the west. And we have compared the cost of testing these 300 water sources on a monthly basis. The 3 models are displayed here. The first one is centralized, and this is where samples are collected and brought back to a central laboratory for analysis. The second model is semi-centralized. Samples are brought back to 4 different laboratories across the district. And the third model is decentralized, and this is where water quality testing takes place at the community level. The graph on the right shows the cost estimates. And it is clear that the decentralized community level model is the most expensive. So then we looked at this in sub-regions of the district, and the only area where decentralized community level testing makes sense from a cost perspective was this mountainous region that is so difficult to access and navigate that community level becomes more cost effective than sending staff. So why am I sharing these results? I'm sharing these results so that people can think about these different models and to make the point that oftentimes a central laboratory is the most cost-effective approach. The community-level approach, which sometimes seems to be promoted, only makes sense in a few regions or sub-areas that are very difficult to reach. This concludes my talk. I hope that through this presentation I managed to convince you that water quality testing requires more than a supply-driven approach. It requires more than building laboratories and one-off capacity trainings. I hope I was able to demonstrate the nuanced requirements for a viable water quality monitoring program, both in terms of cost and institutional capacity. And finally, I hope I was able to challenge the popular idea that on-site testing is the way to go. So I will end by providing the several peer-reviewed publications I referred to and by acknowledging the different donors that have supported this research. Thank you very much.